So we're here at the example table, and in this video we're going to be talking about power series. Now, power series is a series of the form sum from n equals 0 to infinity c sub n times x minus a to the n. And this series is centered at a. Now, two things we should note. We set x minus a to the 0 equal to 1 even when x equals a. So this normally gives us 0 to the 0, which is undefined. Well, it gives us 0 to the 0, which is undefined. And our convention is that we set it equal to 1. Second thing to note, we shouldn't really say that a particular function is a power series, but rather that it is or can be represented by a power series. So this is a particular means of representing a function. This is a function of x. It's not a class of functions itself. Trig functions, that's a class of functions. Piecewise functions, that's not a class of functions, it's a way of representing them. Likewise, power series, this is a way of representing functions. Let's take a look at an example. So let's find for which values of x, so for which x is f of x equal to the sum from n equals 0 to infinity x to the n over n defined. This is sometimes called, this collection of x for which this power series is defined is sometimes called the interval of convergence, because it's the value of the values of x for which this series converges. And we're defining f to be that value when that value is defined. So let's apply the ratio test. We'll look at the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And this means that we're looking at the limit as n approaches infinity of the absolute value of x to the n plus 1 over n plus 1. And when we divide by a sub n, we're multiplying by the reciprocal. So let's multiply by n over x to the n. Now, when we take the limit as n goes to infinity, the n over n plus 1 goes to 1. X to the n plus 1 over x to the n leaves us simply with x. So this limit is the absolute value of x. Now, in a lot of cases, we can ignore the absolute values when applying the ratio test because the terms we're looking at are always positive. Here, they're not necessarily positive. If x is negative, we get some negative terms, so we can't ignore the absolute value. So this limit is the absolute value of x. So by the ratio test, f of x is defined when the absolute value of x is less than 1 and undefined when the absolute value of x is greater than 1. But what about absolute value of x equal to 1? Well, we get two more cases. So case 1, if x equals 1, then this series is the harmonic series. And that diverges. But what happens if x is equal to negative 1? So case 2, if x equals negative 1, then the series is the alternating harmonic series. Which converges. So f of x is defined on the half-open interval from -1 to 1. It includes -1 because that's the case in which we get the alternating harmonic series, and does not include 1 because that's the case in which we get the harmonic series.